Here are some of the definitions of elements, atoms, compounds, mixtures. I'm going to spend most of my time talking about the diagram, so you can pause this and read over this or download the PowerPoint. So this particular diagram here, it's actually very difficult to find YouTube videos that actually correctly describe what an ionic compound is. And ionic compounds are actually formula units. So if there are positive and negative ions, this is the lowest whole number ratio, and that's what the formula unit is. Now, molecules are slightly different because they're covalently bonded, so that is actually the particle that you see. And these are elements, so these are pure substance elements particles, and these are compounds because they're two or more elements. So this one is 2 greater than or equal to 2 elements, and this is just one, only one element. So that's the difference between these two types of pure substances. Now, so what we can see here is we can have elements can be atoms by themselves, or they can be covalently bonded here to be molecules. The compounds here, they can either be in the form of covalent, or they can be in the form of ionic, and we'll talk about polyatomic ions in a second where they can be both. And so what you have in chemistry is these chemical processes. So chemically, we do various chemical reactions in order to get from element to compound, or from compound to element. Now, there is one other thing that we do in chemistry. Actually, it's this kind of three that I can think of. So we do reactions, we do detection, and we do physical processes. So we do things like filtration and decanting and distillation. We do all those sort of things. That is not actually a chemical process. They're not chemical reactions. We're doing physical reactions there. So what we're doing is we're either mixing two things together, but most likely we're doing the opposite. We're trying to get something that we can use, and so we're trying to separate and make something pure, usually getting rid of everything else and trying to get the thing that we want and get it to a pure substance. So the types of mixtures we have are homogeneous, which means the same, so you can't see it. So salt water is a good example. It's many different types of chemicals, but you can't tell. Heterogeneous, I'm just trying to think. Most people know what bubble tea is now. I'm sorry to refer to that one. So that's a drink with these black pearls in there, and you can quite easily see that is two separate things that you're drinking. Obviously two separate things. Obviously you're drinking probably thousands of different things in trace amounts, but obviously maybe 10 different ingredients in there. So that's hetero, that's different, like male and female, and this is just one, so it's all male or all female or whatever. And so that's the two different types of mixtures. So I'm just going to check that. I'm just going to add just a few other points here. So the positive ions, this is sort of probably revision. Positive ions are cations, negative ions are anions, and it hopefully is revision. Elements have the same number of protons, but they can have different numbers of neutrons, and then we will have isotopes. So different number of neutrons leads to isotopes, and I think we've covered it all. I won't go into protons, neutrons, electrons in too much detail because that's topic 2.